Okay, we're now going to do nomenclature of binary ionic compounds, which occurs between a metal and a non-metal. Okay? These form monatomic ions. They form crystal lattices in three-dimensional space, and they form monatomic ions. And we're going to be using the term oxidation state, which is sort of a description of the, is there a charge around the ion or not? And for monatomic ions, the oxidation state is its charge. Now, metals lose electrons, so they form cations. You're required to understand what the term cation is. Non-metals gain electrons, so they form anions. So a cation is a positively charged ion, and anion is a negatively charged ion. We noticed that there are two types of metals, and we're going to look at the first type in this slide here today, in this presentation. And these are the type 1 metals, which have an invariant oxidation state. That is, they only have one positive charge state. Okay? There are other metals which are a little bit more complicated, and we're going to call them the type 2 metals, that have more than one cation. Okay? So iron can be a +2 or a +3, whereas sodium can only be a +1. Now we're going to look at the type 1 metals, okay? And I have hydrogen in this slide because I want to bring it to your attention, but it doesn't form a cation, because if hydrogen loses an electron, it becomes a subatomic particle. Instead, hydrogen forms acids, but its nomenclature is very based on the type of salt it would form as if it did form a +1 cation. So the alkali metals and silver always form +1 cations. And you can understand this because if they lose one electron, they have the same number of the nearest noble gas. Okay? And this is the principle for these type 1 compounds. Alkaline earths, zinc and cadmium, for the alkaline earths, if they lose 2 electrons, they have the same number as the nearest noble gas. Zinc and cadmium and silver, you have to memorize these. It's a little bit more complicated. These are transition metals. Aluminum, always +3. Gallium is also always +3. Now the nonmetals, they only have one monatomic charge state. If the halogens or hydrogen gain one electron, they have the same number of electrons as the noble gases. If hydrogen gains an electron, it becomes isoelectronic to helium, a noble gas, and it can form an anion, okay? The group 6 nonmetals, sulfur, oxygen, can gain 2 electrons. The group 5 can gain 3. Remember, we're saying nonmetals, okay? Bismuth is in group 5, but it's a metal. It doesn't form an anion, okay? So, metals lose electrons, nonmetals gain electrons. The type 1 metals only have one type of oxidation state. Now what we want to do is go over the nomenclature, and the nomenclature is real simple. Okay? You write the metal name first and the nonmetal second, and you change the ending to IDE. So common table salt, sodium chloride, NaCl. Now note, barium chloride, barium BaCl2. This is a binary. Binary does not mean you have 2 atoms. It means you have 2 types of monatomic ions. So barium is an alkaline earth. It's always +2. Chlorine is a halogen. It's always -1. So to be neutral, you must have 2 -1s for every 1 + 2. And we'll go over that in another slideshow.